Welcome to chapter 10. It is going to be radical. Actually, we're just talking about radicals. So what is a radical? It is something that if you don't understand the terminology for, you're going to be quite lost. So lots of terminology here, so pay attention, okay? Fill this in on your notes, pause the video, and fill this in on your notes. I'm not going to pause the video, I'm going to have you do that. So this symbol here is known as the radical symbol or the square root symbol. Okay, we read this as the square root of 9. 9 is the radicand, so what's underneath is called the radicand. 9 is an example of a perfect square. We did with those in chapter 8 and in chapter 9. So all positive radical expressions have two roots. They have a positive 3 or a positive 3 or a negative 3. Okay? Pause that and get those down. But I'm gonna, start talking here. So it's gonna be important that we know our perfect squares in this lesson and in this chapter. So it's going to be something you want to really use this chart and really start to memorize it. You want to know these. So it's going to be kind of like a puzzle as well. We're always going to use this property that if anything underneath the radicand, if there's two things that being multiplied, or we could divide them evenly, then we could write them as separate radicals multiplied by each other. And that'll make more sense in a minute. So here, I've got two methods that I could do this. I could take the square root of 4 and square root of 25 and deal with those. Or I could multiply it together and find out what that happens. So what do I mean by that? So if I take method 1 and I use the square root of 4 times the square root of 25, we know that those are both perfect squares. So the square root of 4 is equal to what? 4. No, I take that back. 2. The square root of 25 is equal to what? 5. They're being multiplied, so then I take 2 times 5, and I get 10. Okay? In that same concept, we could take my square root of 4 times 25 and put it underneath and get the square root of 100. Well, in this case, it happens to be a perfect square because we started with two perfect squares. So what's the square root of 100? It's 10. So I get the same answer, two different methods. Sometimes it's easier to do method 2. Sometimes it's easier to do method 1. It is important that you pay attention how this works and why you would want to do certain things, because it's not just always do it that way. It is sometimes method 1 will work better, sometimes method 2 will work better, and you have to think about what's going on. This isn't just something that you're just going to look at the process and do. You have to think in this lesson, okay? So if I looked at this one, 36 times 9 underneath the radical, there's two ways that I can apply that property. So I could use method 1, which was take the first number under the radical times the second number under the radical and have separate radicals like we did in method 1 before. What's that going to be? I'd like you to figure this one out for your notes. So what is this? What is this? Multiply them together, get me an answer, okay? Or you could take that original problem and you could actually do that multiplication. What is 36 times 9? Well, it's 324. Now, the thing I need to do now is use my calculator, because I don't have perfect squares all the way up to there. Use your calculator, and you're going to do the radical symbol, and then you're going to do 324, and then you're going to do the equal sign. Okay? So that's what you're going to enter. Figure that out on your calculator and bring me a number. So both of those two problems you need to have answers on for your notes. Okay? So that's what we're doing if we're using this property and we're multiplying two things. But we can also use that property to solve stuff. So we're going to look at the square root of 50. And what you want to do is you want to look for the perfect square factor. So what are the numbers that multiply together for 50 so that we could use method 1? And I'm also going to teach you a second method. So we want to write all of our answers in standard radical form. So standard radical form is the largest perfect square is removed or on the outside, and that's our shoes, and that'll make more sense when I explain method 2. And that's going to be multiplied what is left underneath the radical sign. So for instance, that might be 3 times the square root of 2. Okay? So 3 was my perfect square, so that was 9, was underneath the radical, times 2, so this would have been 18. This would have started out as the radical of 18, okay? Because 9 times 2 is 18, and we would have taken that out. So let's look at what I mean by that. So method 1 would be using our property to find the perfect square. So what is the largest perfect square? Use your chart. Inside of 50. What's the largest perfect square inside of 50? Well, it's 25, because we can do 25 times 2, right? 50 is equal to 25 times 2. So this second step, if you're going to do it this way, is always going to be the two numbers that multiply together to make 50, with the largest perfect square being the first one. Okay, or it could be the second one too. It's just easier if you make it first. Okay, so what's the answer to the square root of 25? What's square root of 25 is 5. So my answer here is 5 times the square root of 2. Do I have all the perfect squares out of underneath the radical? I do. Okay, so here's another method that you can use. If you don't like this, or you can't figure out what two numbers multiply that are perfect squares to this number, you can always do what's called a factor tree. Okay? And on our factor tree, what we're going to do is we're always going to divide this number. We want to start with 2. If 2 doesn't work, start with 3. If 3 doesn't work, start with 5. And then 7. So all of the numbers that are what we would consider prime, okay? So, can I divide 50 by 2? Sure, I get 25. Can I divide 25 by a number? Sure, I can divide it by 5. And 5 times 5 is 25. Now here's where I'm talking about the shoes. Okay? Would you walk outside in a pair of shoes? Sure, you'd wear a pair of shoes out. How many shoes are in a pair of shoes? There's 2, right? You wouldn't walk around with just a left shoe on or just a right shoe on. You'd have both shoes on your feet, unless you were injured, of course, but let's assume we're not injured. So you'd always have a pair of shoes. You'd have 2 shoes on your feet, right? So when we're thinking about shoes and we're thinking about radicals, our shoes, the number is kind of like the size of your shoe, okay? So I'm going to have, I can go out of my house. These 5s can go out of the house because I have 2 of them. I wouldn't want to go outside with one size 2 shoe on my foot, right? The other one's stuck under the bed or in a closet, under a pile of clothes, whatever. So I can't wear this pair of shoes out. I have to wear this pair of shoes out. So that pair of shoes can come outside our house. And we can think of the radical sign as our house, and our size 2 pair, our size 2 shoe is stuck in the house because we can't find its pair. There isn't a pair for the 2 in the number 50, okay? So if you think about your shoes, these can come out because they're in a pair and they come outside the house. Whatever isn't circled, and we can only circle in pairs, whatever isn't circled stays inside the house, and all of the things that stay in the inside of the house will multiply those together, and all of the things that come out of the house will multiply those together to get our numbers, okay? So both methods work. It depends which one you want to use, okay? So let's look at another example. Let's look at 45. So method 1 is finding the perfect square, the largest perfect square that multiplies by another number to 45. So think about what that is. So what are these two numbers? I'm hoping you said 9 and 5. 9 times 5 is 45, right? And 9 is the largest perfect square that we can pull out of here. What's the square root of 9? From our chart, we know it's 3. And then this square root of 5 has to stay because this guy's got to stay inside the house. So this is my answer, 3 times the square root of 5. So now let's do that if we're going to do the other method. Okay, 45. I can divide 45 by 5. I know that. I can divide 45 by 5 because it ends in a 5. I know that. I can divide anything that ends in a 5 or a 0 by 5. Okay, so I do that and I get 9. Great. Now, what two numbers can I divide into 9? Can I divide 9 by 2? No. Can I divide 9 by 3? Yes. So when I divide 9 by 3, I get 3 times 3, right? So these ends of the carets, keep the carets in there. Whoops, I do need to erase that. Start with the first number that the largest number that you think you can multiply that by, or divide that by. You know, 1, 3, 5, 2, 3, 5, 7, stuff like that. Keep this, see, this doesn't have a pair, it's over here. Keep this nice and organized, okay? This can't be a messy thing. This has to be organized, and you have to have the little trees out, the little branches, okay? Now, are there any pairs of shoes? Sure. There's a pair of shoes right here, and that guy's stuck inside the house because he doesn't have a pair. So, we've got 3 times the square root of 5. 5's got to stay in the house. 3 can come out of the house. But when you come out of the house, do you have 2 pair of shoes on? You only have 1 pair of shoes on, right? So only one of these 3 comes out because you're able to put both of them on your feet. Okay? That's important. All right. So that's generally how we get our numbers into standard form. So I would like you to pick your method. I'm going to do 162 with you because I want you to see that tree. And I want you to do 212 on your own. So you pick a method. I don't care which method you use. But you're going to come with number 5 done and number 6 done, written in standard form. Okay? But I'm going to do 162 with you, and I'm going to do the factor tree part because I want you to see how it works with a larger number, okay? So 162 can be divided by 2 because it ends in a 2. So 162 divided by 2 is 81, okay? Can I divide 81 by 2? No. Can I divide 81 by 3? Yes. Okay. Can I divide 27 by 2? No. Can I divide 27 by 3? Yes. What do I get? I get 3 times 9. Now, I'm not fun because I can still divide 9. What can I divide 9 by? I can divide 9 by 3. So 3 times 3. Okay, now you want to circle your pairs of shoes. I have 1, 3 here, and I have 1 pair of shoes here, and now I pull out my shoes. So I have 1, 3 here, I have 1 size 3 here. This 2, can he come out of the house? No, he stays in the house. So he stays in the house. Am I done? No, I have to multiply these together. So that's going to be 9 times the square root of 2, and 9 times the square root of 2 is exactly the same number as the square root of 162, but it's written in standard radical form. Okay? So when you come to class, you're going to have 212 done, and you're going to have them written in radical form. If you want to do the tree, do the tree. If you want to do the perfect square method, do the perfect square method. Each of those have a perfect square in them. But what happens if I multiply numbers together and they don't have a perfect square? So what happens then? So when I'm doing that, I am going to take and I'm going to multiply them together. So 3 times 2 is 6. So my answer here is the radical of 6 because there's not a pair of shoes that I can pull out when I make this multiplication. Okay? If there was a pair of shoes when I multiply this, then I pull that out and I write it in lowest standard form. Okay? Now, what happens? What was my number in front of this radical? It's a 1, right? And 1 times 1 is 1. Do I need to write that 1? I don't. What about number 9? So in number 9, I've got a number in front. So I need to multiply that. I need to multiply this. So I'm going to do 2 times 4. And then I'm going to do my radical 3 times my radical 5. Are there any pairs in here? There aren't. So I'm going to keep those underneath, and I'm just going to multiply. I'm just going to multiply. Come with an answer for this, please. What's my answer for number 9? What's my answer for number 9? Now, number 10 is a little bit different. We're going to apply our rules that we had for chapter 7 on this one. So I'm going to distribute this 2 in. So I'm going to get 3 squared times the square root of 5 squared. Okay? Now here's what's really, really cool. We know that squaring something undoes our square root, right? Squaring something is opposite of square rooting, and square rooting is opposite of squaring. We did that just in chapter 8 when we were doing our difference of squares. Okay? Am I done? I'm not. So 3 squared is 9. But now here, because this undoes this squaring undoes the square root, I just have a 5 here. Not 2 5s, just 1 5. But it can come out because I did the square root of 5. When I squared it, that's the same thing as the square root of 5 times the square root of 5. Okay? Because they're both underneath, I can pull the 1 out. Okay? That's why I say it undoes it. All right? So then 9 times 5 is 45. Okay. There's one last problem. One last problem that we have to do, which is going to be kind of tricky because we need to distribute this in. And we want to see what happens. Okay? So 6 times 3 gives me 18. 6 times 3 gives me 18. Both under the radical. You know, that comes under the radical.
And now I'm going to do 6 times 6. What am I going to get? I'm going to get 36. I'm hoping that you notice something. I'm hoping that you notice, hey, there's a 3 in here and there's a 3 in that 6. So if I'm going to do this right, I can do both methods. So I can do the square root of 9 times the square root of 2 because I can't leave that 18 like that. It's not in standard radical form like this. So I have to simplify this. And I can do 9 times 2 is 18, right? And now the square root of 9 is equal to 3. And I'm hoping up here, you saw there's a 3 in here, there's a 3 in here. That 3 is going to come out. And then I'm going to have that 2 left over because of this 3 times 2. I'm hoping you saw that. But if you didn't, look for it. Look at what I'm talking about. Okay, now let's do the square root of 36. Is that simplified? Can I simplify it easily? I sure can. That's one of my perfect squares. Whoops. Didn't mean to erase that. Plus 6. Now, can I add these together? Can I add these together? Are they like terms? They're not. This is like a 3x, where my x is equal to square root of 2. And this is like just a 6, just a constant, a c, okay? So 3 times x plus 6, I can't combine those because this is like, this is not a like term to this one. If this had a square root of 2, then I would be able to combine these and add just the front numbers together because it's just like sorting our pencils or sorting our apples, okay? So can I combine these? No, because they're not like terms. All right, I want to see the answer for number 9, number 5, and number 6 worked out for your notes. Have a great night. God bless.